is the hypothetical spaceship design that's partly or entirely organic. This could mean a deep space vessel with a vast hydroponic system, ready and capable of providing an entire crew with reliable food and energy. Or, in more extreme versions, a bioship can be a living, breathing creature in its own right, born and raised in space itself. In the eternity of the universe, a bioship allows a crew to still live off the land. Excitingly, we're already conducting various experiments into how outer space affects living things, not only for astronauts, but also for animals and plants. Over the years, plenty of vegetables have been successfully grown on the International Space Station. And we know that plants will inevitably play a vital role in the future of space travel because they produce oxygen. For many and most scientists and researchers, the near future promise lies most with hydroponics. Hydroponics is a way of growing and farming plants without needing soil. So given that any future space mission could be a long way away from Earth, and that carrying soil just isn't feasible because of the weight, a large-scale hydroponics facility on board any ship could be enough to ensure the crew doesn't starve or suffocate. Large-scale space habitat designs, such as O'Neill cylinders, allow room for enormous stretches of hydroponic greenery to provide food, oxygen, and comfort to anyone living on them. On a smaller scale vessel, busily moving between the stars, it's not quite as possible for fields and fields worth of soilless vegetables to be on show. But there could still be whole sections of a spaceship dedicated to sprouting life. The main challenge here would be in managing a steady water supply, and also in combating the effects of microgravity on plants, which is something else that astronauts are currently studying. For some researchers, however, much more needs to happen. And we need to change how we fundamentally build space structures first of all, before we start fitting them with cosmic greenhouses. David Barnhart, a lead engineer at the University of Southern California, co-wrote a paper on the issue with Bioterra Bucharest University's Nicole Livia Autu-Dacier. He argues that we should more closely model spacecraft designs after the natural world, and that we therefore need to invent a new kind of either hybrid or fully organic material to build bioships out of. Something that's partly alive and partly synthetic, that can actually grow and change to suit different purposes. Now it's all about flexibility. Gone would be the days of the stark, lifeless, custom-built for specific needs modules of the ISS, and instead we'd have more adaptable, dynamic modules. Structures that Barnhart has previously called satlets. These, he imagines, would work similar to how a coral reef does. Corals are all different creatures, but they're tightly woven together to form a reef ecosystem, which then goes on to support plenty more animals and plants as it evolves over time. For Barnhart, a successful spaceship should do the same thing. It shouldn't be limited to the clunky design it originally had whenever it was first built, but it should instead develop and morph with the ever-changing landscape of space and for the ever-changing needs of its crew. The fact that we need a new kind of material for this venture is the main reason why nothing like it has even been started yet. But as a concept, ideas like this are what pushes science and technology forward. And suddenly, even the ISS, arguably the most advanced thing we've ever built, begins to look out of date. If we could develop something that could physically grow over time, then it would give us some enormous advantages in space. Long-distance crews would now be able to continually update their far-flung home by planting and nurturing new parts of it, creating more space, but also more possibilities and functions. Depending on how our hypothetical base material worked, it could even seed like corals and plants do, making storage and transport so much easier. But most fictional bioships aren't either of these things. They're not just massive, clinical-looking hydroponics farms stretching out across the sky, and they don't rely on a theorized material that might never actually be invented. Instead, the bioships in sci-fi are usually living, breathing organisms in themselves. Alien ecosystems or mysterious creatures, the likes of which we've never seen before. And at this stage, the truth is that if this is the type of bioship we want, then we might not be able to build one at all. We might have to rely on bioships finding us instead. On an alien mass or creature arriving in our skies, revealing to us things we never considered were possible before. But what are the chances of that happening? It's not completely beyond the realm of possibility that a living object could be moving at incredible speeds and warping space-time around itself to move between the stars, all while safely surviving in the vacuum of space. But it's not that likely either. And even without the speed, the probability that we just discover a living spaceship such as that is extremely low. As modern science tells us, trying to find life on even notably Earth-like exoplanets is difficult enough, let alone trying to find it in all the cold and empty places between those exoplanets. If we did find a bioship, it might realistically be about the size of an asteroid, too. Almost impossible for our current telescopes to pick it up. And while it would be emitting some electromagnetic signals, they would be hard to distinguish from those leaking out of any other celestial phenomenon. But according to some of the more far-out theories, the main prospect of life aboard is one of the main reasons why astronomers have been so excited by the Oumuamua mystery in recent years. There's no solid proof that it is a bioship, but its journey through the solar system has gotten our imaginations turning regardless. So say we were able to either find or develop a bioship of our own. What else would change for us? Well, the importance of AI in the future of space travel could lessen if even our ships weren't traditionally mechanical or digital anymore. Any onboard AI would no longer be seen as an extension of a spacecraft, but only as a guardian or a navigator, as a standalone machine or a system designed to extend the life of the bioship first and foremost. But the control would lie in however it was that the ship was growing and living. Even in the dark expanse of space, on a bioship, nature rules. The skills required to be an astronaut on a bioship would be wildly different too. Rather than specializing in machines and engineering, bioship pilots would more likely double up as ecosystem ecologists, systems biologists, or botanists. A broad knowledge of the life sciences would now be what was most needed when traveling through galaxies. You'd need a unique brand of survival skills too. And in the same way as any astronaut has to be, you'd have to be versatile, able to adapt to any situation. Because on a bioship that grows and governs itself, life would certainly be unpredictable. But what's the worst-case scenario here? What happens if the ship gets too smart? Sentient AI running amok in deep space is a popular story arc in conventional science fiction movies. But now we'd have that same scenario, only from an astrobiological source. A ship that grows for itself, heals for itself, and thinks for itself could be very difficult to pilot at all. For as long as it was less intelligent than its human crew, there needn't be huge problems. But as soon as it surpassed human intelligence, then those on board would live at its mercy. We know from just life on Earth that nature can be cruel, so if it turned against us in space then, ultimately, we'd be helpless. In all their thriving, teeming, organic glory, bioships offer a different route to the future. For so long, most ideas on what space travel will look like have included the crisp, clean lines of gleaming, state-of-the-art, non-living ships. We tend to imagine bright corridors between shiny living spaces and a control room that flickers with the lights of 1,000 switches and gizmos. But bioships have none of that. Instead, they're unruly. They change shape over time, they grow with their crew, and they potentially think for themselves. Would you want to live on one? Could you imagine scaling the universe cocooned in your own self-evolving ecosystem, for better or worse? You'd be on both a final frontier of humanity and your own private island in the cosmos. Because that's what would happen if humans built a living spaceship.